The first thing we have to find is the size of the angle ACO. And to do that, we're going to use a circle theorem, the one where the angle at the center is double the angle at the circumference. And applying that in this situation, we will find that ACB is 1.4 because it's half of 2.8. We then can realize the two triangles ACO and BCO are congruent triangles. They both have sides of little r, and bigger. And so the angle ACO is going to be half of ACB, which makes it 0.7. To relate the capital R to the lowercase r, we can create a right angle triangle here with the angle of 0.7, and notice that the lowercase r is the hypotenuse, which means the side adjacent to the 0.7 is little r cos 0.7. But that side is half of the length of r, and so r is equal to 2 times little r cos 0.7. We can put 2 cos 0.7 into the calculator and come up with that r is 1.53 lowercase r. That's rounded. We should store the actual value in a variable on our calculator so we can use it again later. So to find the shaded area, we're going to have to be a little creative here. We can use the sector on the small circle to find the area of the sector, but that includes too much. We can find the area of the large sector as well, and that includes the area that we want to subtract from the small sector, but it has extra area as well. So we could find the area of the triangles, subtract it from the large sector. That leaves us with the area that we want to subtract from the small sector, which gives us the shaded region. So the small sector area is going to be a half r squared 2.8, which is just 1.4 r squared. The large sector, we're not going to use the capital R, we're going to use the lowercase r version that we found related to capital R, and we get a half of, which is now in brackets, 1.53 r close bracket squared multiplied by 1.4, which is the angle. And if we put that into a calculator, we'll get approximately 1.64 r squared. Remember, we're using exact values on our calculator to solve this. From there, we can work out the area of one of those triangles by using a half AB sine theta. But in this case, it's a half r squared because the two sides are the same length, sine, and we have to work that out. Both angles are 0.7, so it's going to be pi minus 1.4. And there are two triangles, so let's multiply it by 2, and we can find that area of both triangles is 0.985 r squared. Okay, so to find the area of the large sector that we want to use, we take the area of the large sector, subtract the area of the two triangles, and we end up with 0.653 r squared. I'm always using exact values on my calculator, just giving rounded values on the screen, which then means our shaded area is the area of the small sector minus this area we found, and that turns out to be 0.747 r squared approximately.